Okay, a little more on the 1915 build. So I've got the crank in, all ready to go. Crankcase is ready to go together. I've had it together twice now, torqued up, rotates fine, cam backlash, clearances, the whole works. This is a gear drive setup in this with an FK41 camshaft. You can see I've got clearance bolts in there for the oil pump because it's a larger oil pump and it sinks in a bit. You got to make sure there's clearance behind the back side of the pump. Gear drive setup, and I did time it. It is timed. Just happens to be sitting in the position to put the cover on. O-rings on, lubricated, cam lube, thrust bearings, double thrust bearings. So the lower one here on the pressure side of the case. I cut the back tang off of it, file that down, and then make sure they fit for the backlash is correct. And I run usually about 3 to 4 thou in there. As long as you got a bit of clearance in there, you don't want too much. And again, you want to check that in the other case half also when you're putting the cam together. So you want to check it on that bearing there, which is the OEM position for the double or the single thrust bearing with the tang. So on the other side, there's no slot in the case. Some guys will carve a slot in the case. I just carve the tang off the back of the bearing and then it sits down in there fine. And from prior builds, I never see any issues with any abrasion here from a high spot from doing that. So that side of the case is ready to go together. Just got to lube the end of the lifters. I just don't want it dripping off until I put the cover on. So I'll glue this side of the case and then install it onto the engine here. So you're not squeezing out and you only have one film. And this one, again, like in previous videos, I've got the outlet plugged because I'm running full flow going back in to feed the main gallery. All new bearings, a line board, new drive set on here. Obviously the cam spur cut gear straight cut, racer spacer, new distributor drive, and then of course the snap ring. I find I have to compress them a bit and then be very careful of not overstretching them so they stay tight on the annulus groove of the crank. I just line my bearings up with a notch at the top so I know that they drop down into the pins. And again, she's all ready to go. And something else too on this particular crank, it's a straight cut crank, and then the cross drillings are done with in the machine shop when they manufacture it, and then they cross drill it this way, and then they put a plug in the gallery or in the end of the counterweight. So you're going to make sure you take them out when you have the crank. Well, prior to me building this, take them all out, flush the crank, run brushes through it, and get any debris out of there from manufacturing, and then torque them in with some Loctite, and so they're not going to come out. So ready to go to put the cover on. And again, this is a counterweighted crank, 69mm crank. I've got the pistons all ready to go here. I stack them all up like this, then put the pins in, and then I'm going to use these particular spiral lock retainers as opposed to using the standard clips, because these do break. They collapse, they lose their spring tension, and then they become loose and they rotate in there, and then they can add some material and start causing some issues in the cylinders. So number one's all set up there. I haven't finished. Each one of these are lapped into the cylinder heads, but I haven't finished assembling this because I need a stack up. And what I mean by that is when I put the connecting rod or the piston on the end of the connecting rod and the cylinder sleeve on with the rings in place. Some guys will do it without. I mean, I've done it without and with. And then you want to measure your deck height so you can establish if you need to run any shims under the base of the barrel to adjust to get yourself 40 thou of deck height. Now the heads that I'm using on this are these MP heads, and these are the CNC ones, double valve springs. I'm going to run the, so that you can see the dark ring around the outside of them. That's where I've lapped in the barrels, and you see I've got them numbered, and I match all the barrels to the lapping. But those heads there with the double valve springs having that extra thrust in the bottom end here is going to help reduce the load on the camshaft. I am going to run a 1.4-to-1 ratio rocker on this, which will give me like a 509 lift, and I can't remember what the duration is on that FK41. I think it's like 278 or something like that. So it should be done around 5,500, but should be pretty good in torque in the bottom end. So we'll see where we get to. So I'll have to do that stack up to find out what the compression ratio will be on the engine. So I've got 55 cc heads. I did cc them. Yeah, they're 55 cc heads. So I may have to shim. I may have to deck the heads, or I may have to take some off the barrels to get the compression ratio right. So I want to try and put it together with 0 barrel fire. It's going to be all in the combustion chamber, and having 55 cc's for a chamber is pretty big. I mean, I built engines down in the last one I had it was pretty low, 32 cc's, and it was like about 11.5-to-1 compression on that engine on a 1600, and it worked really well. No problems with the heads or anything, but getting down to like a 30 cc chamber is getting the head very thin in the mating area in here. So once you start taking material down, you're removing all this material all the way over to the edge, so it actually thins out how thick the head is, and then you can blow through the head or cause, have metal related failure problems from not having enough deck material available. So here's a pump that I am going to run. It needs to be cleaned up, but it has the outlet plugged on it too. So I plug the outlet on the pump, and I plug it on the block so you don't get any pressure coming back in and causing premature leaks around the housing of the pump. On the back, I'm going to run one of these aluminum plugs. I find these to be pretty good. There's an O-ring in there, and then lather it up with some whatever flavor of sealant you like. I use an RTV type of sealant I think it's good for 675 degrees, and it's meant for aluminum engine cases. So, and it seems to be pretty good. I've had really good luck with it. Anyways, there we go. Continuing on with the build.